Today we're going to talk about multiplying fractions. So let's start simple. If I ask you what is 1/2 of 8, most of you could tell me that half of 8 is 4. Likewise, this is the same type of problem. I'm asking you for 1/2 of 2/3. Well, here I have a picture, and this is a rectangle broken into 3 equal parts. Therefore, each part is called 1/3. I have shaded 2 of those thirds, and now I want to find half of the 2/3. So if I have 2/3, half of that would be this, which is the same thing as 1/3. When you see the word of, it means to multiply. You can also do the math to find the answer. The first thing you would do for 1/2 of 8, or 1/2 times 8, is to make the whole number a fraction by putting it over 1. So I have 1/2 times 8 over 1, because 8 over 1 is the same thing as 8. And then I multiply the numerators. 1 times 8 equals 8, and 2 times 1 equals 2. When I'm finished, I check to see if this is in simplest form. And I notice that this is an improper fraction, so I need to change it to a mixed number, or in this case, 8 divided by 2. 2 goes into 8 4 whole times. So 1/2 of 8 is 4, just like we saw on the board prior to this one. The same problem from the first board, 1/2 times 3rd. Again, we can do the math. We multiply the numerators, 1 times 2, and that equals 2. And then we multiply the denominators. 2 times 3 equals 6. When we're finished, we check to see if we can put that answer in simpler form. And in this case, 2/6 has a common factor of 2, so we can divide 2 by 2 and 6 by 2. 2 divided by 2 equals 1, and 6 divided by 2 equals 3. So we have that 1/2 times 2/3 equals 1/3, because that's really the same thing as half of 2/3. Now remember, the answer to a multiplication problem is called the product. Let's try a few more. 3/5 times 1/4. I multiply the numerators. 3 times 1 is 3, and 5 times 4 is 20, because I multiply the denominators. Then I check to see if that can be simplified. And in this case, there is no number larger than 1 that goes into both 3 and 20, so 3/20 is my final product. Let's look down here at 3/8 times 2/5. Again, I multiply numerators. 3 times 2 is 6. 8 times 5, I multiply denominators. 8 times 5 is 40. And then I need to see if I can simplify. And in this case, I know that 2 goes into both 6 and 40. So I'm going to divide 6 by 2 and 40 by 2. 6 divided by 2 is 3, and 40 divided by 2 is 20, which gives me 3/20. And it just happens to be a coincidence that 3/20 and 3/20, I get the same answer on both those problems. Light bulb! There's another way that you can sometimes simplify before you multiply. Look at the case of 3/8 times 2/5. We just did that a minute ago, but look at what you can see. It says, see if the numerators and the denominators have a common factor larger than 1. Let's look at the numbers that are diagonal to one another. 2 and 8. there's something that goes into both 2 and 8 besides 1, and that is 2. 2 goes into 2 one time, and 2 goes into 8 4 times. Now I can check the other diagonal as well, 3 and 5. But I know that since 3 and 5 are both prime numbers, nothing goes into 3 and 5 besides 1. So I keep those the same. And then I simply multiply. 3 times 1 is 3. 4 times 5 is 20. Now again, remember, this is the product. It's the same problem we worked on the prior board, but what we did is we simplified before we multiplied this time. Let's try another. 3/4 times 11/12. Again, look at the numbers that are diagonal to one another. 4 and 11. Does anything go into both 4 and 11 besides 1? No. So I cannot simplify here. But look at 3 and 12. Does anything go into 3 and 12 besides 1? Yes. 3 goes into both of these. So I divide 3 divided by 3, and I get 1. And 12 divided by 3 gives me 4. Now I have 1 times 11, which is 11, and 4 times 4, which is 16. And this is in simplest form. And I'm finished. Now let's look at one more situation. You can check both diagonals, like I said a minute ago, and see if you can find a greatest common factor and simplify before you multiply. Let's look at 5 and 15. 5 goes into both 5 and 15, and so I'm going to simplify now. 5 divided by 5 equals 1, and 15 divided by 5 equals 3. Likewise, if I look at the other diagonal, I see 8 and 12. 4 goes into both 8 and 12, and 4 goes into 8 twice. It goes into 12 3 times. So now I have new numerators and denominators, and I multiply those. 1 times 2 equals 2. 3 times 3 equals 9. And 2/9 is already in simplest form.